And I'm very happy to invite the chief guest and the Honorary Secretary of Uttar Pradesh, Engineer Vijay Pratap Singh, to give a lecture on upcoming green technology in marine engineering. And I will be wondering that before COVID, we never thought of connecting the people through online. We usually conduct the conferences, workshops, and research lectures or research meetings only physically. But the COVID make us to use the technology very effectively. Here also in engineering institutions, we are running the engineering courses, 4-year courses, degree courses. And each and every year, we have to provide a classroom. For example, we are running a civil engineering course and we have to provide 4 classrooms. But I thought of that, why we need 4 classrooms per 4 year? It can be on rotational basis. The technology may vary places and maybe reduce the area of the classrooms. Now the AICT says that you can have only 2 classrooms. Other 2 classrooms can be rotating or effectively for use of the classrooms. So like that, now the technology uniting us. I may be in Salem and you may be in Uttar Pradesh and other members in different places. But within a fraction of second, we have been united and we are gathered here to hear the lecture from a VP Singh, Engineer VP Singh. So on behalf of the Institution of Engineers and all the members, council members, committee members, and all the corporate members, and from Tamil Nadu State Center and the other area may be connected, the students may be connected here. I am very happy to welcome Engineer Pratap Singh for giving the lecture on upcoming green technology, especially on marine engineering also. For me, the marine engineering is a very interesting field. I hear a lot of stories by my relative. One of my relatives working as a marine engineer. I always heard the stories, how you are facing the challenges. What are the challenges while you are sailing? What are the challenges you are facing while you are sailing? How you can overcome the challenges also. A lot of stories I heard that. Once in 6 months, I will be meeting him and also hearing a lot of stories. But I never traveled in a ship. But today morning only I thought of that at least I have to travel nearby country, maybe Andaman also. It is a wonderful experience that people are telling that. And this is also a green technology. Without doing travel, without spending money, without spending our energy, now we have been united with the means of biotechnology. It is also a kind of green technology. So today I am very happy that we invite the Honorary Secretary of Uttar Pradesh, Engineer VP Singh, for delivering the lecture to Tamil Nadu also. So now we have been uniting with the Uttar Pradesh also. Now the elections is going on in different places, on different places. Now I am very, very happy to see VP Singh, sir. I am very happy to welcome for this lecture, sir. And I am very thankful to our Honorary Secretary, Gogul, also for arranging this wonderful, Swami, sir, and my staff members working in the IEI. And we have a meeting on Saturday. So on this occasion, I invite all the council members and committee members who are connected for meeting. You are all welcome for our committee meeting, and also you are all welcome for telecommunication day celebration day. Thank you very much. We are very happy to hear and we are eager to hear your lecture, sir. Thank you very much. Thank you very much. Thank you.
Yes, sir. Yes, sir. Thank you so much, sir. So before our sir, 1 minute, sir. Before our speaker to initiate this lecture, I would request our Muthuswamy sir, who is a committee member of Marine Division, to introduce our speaker to our audience.
Okay. Thank you, Mr. Gogul. And I welcome Mr. VP Singh, who was almost 25 years as a chief engineer on board various ships. Let me give a small briefing on his background. He was a graduate marine engineer, DMET, Calcutta. That was one of the very, very famous for the marine engineering research in India. One of the top institutes in India. Was graduated from 83 to 87. And he joins as an engineer on board Shipping Corporation of India. He went on a various ship on the various positions, and he became a chief engineer in 1996. And 97 onwards, he went on overseas. He worked with various companies as a chief engineer, different nationalities, different kind of management he must have met. He had a very vast experience, I can say. 25 years is not a joke for a chief engineer. It's a very vast experience. He must have seen so many things in his lifetime experience. And he also has a award, HS War Memorial Award for the best technical paper presented in IME, Institute of Mechanical Engineers, 2007 and 2008. And he also presented various papers in the IME magazines. And quite number of papers is presented. Fellow Institute of Engineers and fellow Institute of Mechanical Engineers also. Mr. VP Singh, you had a great experience. Thank you very much for coming here and giving us the lectures. The dais is yours. Please take over.
Malay Vadakkam, Namaskaram, and good evening. I'm honored to be invited by Tamil Nadu State Center. I thank Dr. Karthikeyan, Honorary Secretary Engineer Gokul, and Engineer Ramaswamy for introducing me and giving me this opportunity. Now, marine industry is a globalized industry and very critical for goods and services to be moving across the globe. That is for human survival. It is very, very important. And for India's economic growth to a 5 trillion and more above, this industry is going to play a very large role in its success. Now, what is the benefits of shipping? Main features. Yeah, somebody is speaking. What are the benefits of shipping? It's the most economical mode of transport per ton mile. Most environment friendly transport because it is 1/6 of the CO2 emissions of a road transport. And it connects the mainlands and islands. But India has for India to grow, we have our port infrastructure and all other things have to improve. As the economy grows, we'll have to also improve. And plus, there are strict environmental regulations being imposed by International Maritime Organization, which is based in London. And for the greenhouse gas emissions, shipping industry is always taking first step in this. Now the goals are that we have to reduce the carbon footprint, enforcement of environmental regulations, and in the competition, at the end, it is the benefit of the consumer. So there should be a low cost to the consumer. So consumer benefits are also important when taking all these factors into consideration, because if it's a high cost, nobody is going to use it. Now, why it is the carbon footprint reduction is a major concern for the shipping industry. So we move on to the next. The shipping industry consumes about 300 million metric tons of fossil fuels. That is mostly the black oil or the furnace oil or heavy oil, what it is called. And this 300 million tons creates about 1 billion plus metric tons of carbon dioxide to the atmosphere. Of course, it is not that much because it is just similar to annual greenhouse emission from Japan, which is the third largest economy right now. But still the International Maritime Organization is taking a very proactive step to reduce the emissions. And this is they want to just maintain it 30% above the 2008 levels. They have created a timeline that by 2050 that this industry will have a zero net emission, zero, and so that the global rise of temperature is kept to not more than 1.5 degrees. Now, as we are moving towards that, this is the timeline that we bring it down by 20 to 30% and 70 to 80% by 2040 and 2050 net zero. Now, how do we reach there? Right now, presently, what they are doing is they are gathering the data from ships and they are trying to reduce the consumption. Now, one of the very effective, cost effective is slow steaming, where the ship speed is reduced. And there have been studies where they say that if you reduce 25% speed reduction, the consumption goes by 58%. So that means the greenhouse gases will be reduced by 50% for that particular voyage. So it's a effective way to, these are the measures right now are they already put in place and they are working on it. Plus newer technologies are being explored and being thought about and researched, and it has to be synergized between the engine manufacturers, the shipping, shipbuilders and the ship owners. Now there are alternative sources of energy. Now, one of the main sources was LNG, LPG, hydrogen, ammonia, methanol, and even solar. Solar is not that feasible, but wind power, there have been some trials in Japan and even in Europe for using sails, but it is still in very trial stages only. There's nothing, not major, it's only the prototypes which are being tried on. And most important is the reliability of the vessels, because what happens if certain goods and services don't reach in time for the usage, then there will be a big challenge to the countries and the humanity. Now, zero carbon fuels, if what we call zero carbon fuels, hydrogen is one, but hydrogen has a very low energy density. It is almost 25% of the fuel oil, the gas oil. That means it has to carry almost 4 times more for the same power requirements. Ammonia is another which has been tried on prototypes. But there is a toxicity factor in this. So there will be a safety and environmental concerns in ammonia. Green methanol is another good option. It has power density about 60% of the fuel oil, diesel oil. So the diesel oil, so we'll have to carry more fuel oil, more methanol per ton mile, requirement. And also within the vessel crew, the engineers and the navigators will have to be retrained in using these new sources of energy. So there will be a training infrastructure also will have to be developed. Now we have alternative fuel. Yes, here is the chart for alternative fuel, where the MGO, the specific energy of marine gas oil, is 42.7 megajoules per kg. Now LNG is a good option, but LNG has a temperature storage. The temperature is minus 162 degrees. It has to be stored at atmospheric pressure. So those challenges are there. But its energy is high. It's a high energy. It is 48 megajoules per kg. So it is in fact it is a good source. Now LPG is another source, but the same problem of LPG also is low temperature storage, and energy density also is close to the LNG. Ethane is ethane also similar challenges of a very low temperature storage is required or a high pressure. Now methanol. Methanol is one of the good fuels. The storage conditions, they can be existing storage conditions can be used. But here the problem is its specific energy is only 19.9 megajoules, which is almost 40% of 45% of the MGO. So our storage capacity will have to be increased to meet this requirement for methanol. Hydrogen, the green hydrogen, what we call green hydrogen means that we are producing this hydrogen without any, coal power plant in use. Mostly the solar, they're talking about solar energy being used to produce the green hydrogen. But green hydrogen, again, the storing is a big challenge because of the low temperatures. It has to be maintained. So, and it requires almost 4.5 times more volume to be carried or weight to be carried on ships for the particular journey of the ship's voyage. Ammonia also has a similar issue, but it has an additional problem of toxicity. It is unsafe for the humans around, and environmental issues are also there. It has a low temperature, and the storage volume again for ammonia also requires almost 3 times more compared to MGO, as you can see in the last column. So these are the fuels which are being right now tested and being worked upon and has been progress. Now there has been a German energy agency study that if 95% of aviation could be saved if hydrogen were to replace in coal in blast furnace in steel industry. But this hydrogen, same issue because hydrogen production also requires electricity because it has to be with the electricity electrolysis, the hydrogen is generated. So for that, the new technologies are coming in, and they are working on this green hydrogen technology. Now, for green hydrogen technology, there is a proton exchange membrane, which electrolysis, which helps in electrolyzing hydrogen faster. It has an efficiency, higher efficiency, and it operates at lower temperature and pressure, unlike the usual electrolysis for hydrogen. And there has been a Department of Energy United States study on this green hydrogen when they have put a timeline for improving the efficiency of this hydrogen production. This is a PEM electrolyzer schematic diagram, which shows that how the membrane is inserted between a cathode and anode, and then how the hydrogen moves from, after being dissociated, it moves to cathode and is generated and stored. Now, this is the technical target which has been set by US Department of Energy for electrolyzer stacks and for hydrogen. Now, in 2022, the status was that electrical efficiency of this was 65%. 65%. And kilowatt per hour kg, I mean the material required for that was 51 kilowatt. And average degeneration rate was 40. The lifetime was 40,000. And the capital cost of this in 2022 was $450 per kilowatt for this hydrogen electrolyzer. Now they have put a target for the hydrogen electrolyzer for 2026, that total platinum requirement should be 0.5 gram per kilowatt, sorry, 0.1 gram per kilowatt, and performance has to be better, 69% efficiency it should have, and average degradation rate also reduced, 43. The life of this electrolyzer will be 80,000 hours, operating hours. And the capital cost of the system will be around $100. This is the target they have set for achieving the target, so that the more hydrogen can be produced at a cheaper rate. And production cost is just $2 per kg of hydrogen, whereas in 2022 it was $3 per kg. And the ultimate target which they have put for 2030, this is where they want the hydrogen, the efficiency for this electrolyzer should increase to 77%. Average degeneration rate will remain the same, almost 80,000. Capital cost dropping to $50 per kilowatt. $50 means about 4,200 rupees per kilowatt. Whereas right now our solar system costs about 60,000 rupees per kilowatt. So this way the green hydrogen will be much cheaper. Even if we require 4 times the normal, it is still much cheaper. It will only cost 16,000 rupees per kilowatt in the long run. Energy efficiency is 72% of this. That is the targeted. And production cost would drop to $1 a ton. This is a good target, and I'm sure things will be achievable. Human mind is like that once we put our focus, we are able to achieve. Now next, there have been there are 2 major engine manufacturers in the world for marine engines. One is Wärtsilä and one is MAN. Now they are also already, they are catching up with the new technologies. So in 2022, they had launched a Wärtsilä methanol engine and commercially, and by 23, they have added 4 more engines. Gradually, it is in the trial basis and prototype, and this is, they are working on it, and I'm sure it will become the need of the hour. Right now, the world shipping has more than 50,000 ships. So imagine that kind of capital cost required for new building and renewal of the world shipping will require. Now, Wärtsilä also did in ammonia as well. They have launched a 4-stroke ammonia engine, and this ammonia cuts the greenhouse gases by 70%. This new engine will help ship operators address decarbonization pressure, and it is a stopgap arrangement. It is not a total, because the aim of the International Maritime Organization is to be a zero emission. So this is only on the path to achieving zero emission. It cannot, because here it is still 30%, almost 30% greenhouse gases will get generated for the same requirement. Now this was a prototype for Wärtsilä, and we have now MAN. MAN also came up with a large, MAN has been there in dual fuel engine, there on LNG ships, because what happens when we carry LNG, people must have seen the ships with a spherical, balls, round vessels, 4 or 5 tanks, So they are the LNG, they are basically carrying our liquefied natural gas, that is methane, under pressure. Now what happens in carriage, because of the temperature, the methane turns to boil off. So BMW has come, MAN has come with a system that this boil off gas can be, because to compress it and put it back into tank takes more power. So this boil off gas, which is about 2% of the total cargo, This boil of gas can be used in the engine for running the propulsion. So they have made this dual fuel engine, and they have, some of them have been working, but they have their own problems. But they are still, they are presently in use since early 90s. This technology was started, and especially on liquefied natural gas carriers, LNG carriers, this is the one. But LNG is a very small, 4 to 5% ship are only LNG carriers. Rest are all other bulk carriers and crude oil carriers and passenger ships and other types of ships. So this is one of the MAN is using. Now, MAN has done one more study on a biofuel. They did on a biofuel, mostly methanol it must be. So they have done a study on biofuel, and this ship is already running, and it's a comparative study. The VLSFO is a very low sulfur fuel oil. Like we have this high-speed diesel, where our sulfur weight is less than 0.5, less than 0.1 actually percent. So they have done the study. So if you see VLSFO density is 940, here also density is 940. Viscosity of VLSFO is 98 centistrokes, whereas viscosity of biofuel is 16.6 centistrokes. Sulfur is 0.5%, whereas biofuel has a very low sulfur. This is good actually, because sulfur in fuels can cause the acid rain. That is why the sulfur has dropped from when I started working. The sulfur used to be almost 5% in fuels. Now it is less than 5.5%. So there has been 10 times reduction in sulfur. The calorific value of this fuel of VLSFO is 42.1 megajoules, but for biofuel it is 35, less than close to less than 42, 35 to 42. Now the ship was with the power of 8.8580 kilowatt. That is the maximum continuous rating power. It was running at 108 RPM, achieved 12.5 knots. Slip was 15%, load was 58%, and power that time required for that load was 50.45 kilowatt. Good weather, and their consumption on fuel oil was 22 metric tons per day. Whereas on biofuel, with the similar conditions, with the speed of 12.5 knots and load at 58%, and power was 5,015 kilowatt, good weather, and their daily fuel oil consumption was 24.4 tons per day. So biofuel is a very good option for the intervening period, because biofuel still will have, as long as the fuel has a carbon in it, like it will be either methane, ethane, ethanol, C2H5OH. So as long as we have carbon, we will have carbon dioxide being released into the system, into the atmosphere. So the idea is to take out the carbon from fuel. So that is, the hydrogen comes into, green hydrogen especially comes into that play. Now, one of the newer technologies, which is a no-go areas for most of the commercial shipping, actually is nuclear technology. That I think has not more than 2% or 3% of greenhouse gases emission. It has a zero greenhouse emission. The fact it has to be factory fitted. I mean, from the shipyard, it cannot be retrofitted. It can provide tremendous amount of power. It is scalable. Construction is modular, and there is no refueling. The replacements are there. The fuel rods have to be replaced. It has a high power density. I mean, power to weight ratio is excellent. So there will be saving in dead weight. That means the particular ship can carry more cargo. Its operating costs are reduced OPEX, long fueling cycles. Once fueled, maybe 2 years, the fuel rods not to be. It has a very, very small carbon footprint. Now, the safety factors, because it has got radioactive material, so there's a safety issues are there, the other things are there, and they are a challenge to the nuclear, and the wastage is there. There is hardly any waste, only the fuel waste will be there. That will be not a very huge amount of it. Now there are challenges to the nuclear. First is safety. The risk management has to be there, safety considerations have to be there. Then the regulatory challenges would be there, because it is nuclear as it is a very touchy and a very risky thing. So there will be international atomic energy will be involved in the process. International maritime organizations will be involved in the office. The flag state. The flag state means that the ship which belongs to the particular country, the owner of the ship, and the coastal state. Suppose a ship which is registered in America, a nuclear ship. Now, a lot of countries have this regulation that they don't allow nuclear ships to come to their shores. Like even in Suez Canal, I have experienced that they don't allow nuclear ships to pass through the Suez Canal. So it is a challenge. Operational. There will have to be new regulations coming in. Nuclear maintenance will be highly specialized. It cannot be done. Then terminals have to consider. Then crew has to be specifically trained to handle the nuclear energy, about this, and how when the ship's life is usually 20 to 25 years. So when the ship is being scrapped, then how the nuclear plant has to be disposed or taken care of. Plus there is a spent fuel. There is a problem of because spent fuel becomes highly enriched uranium. So how to take care of that. All that will be there. Now there is a commercial requirement, the CAPEX. The capital cost is quite high for this. For the ships, and trade location limitation, because the countries have to change their own regulations to allow these nuclear ships to come into the system. But I think this is one of the best solutions for greenhouse gases, in my opinion, in my own humble opinion. So that is the targets what the International Maritime Organization set. Nuclear technology has to come into commercial shipping. There are some Russian icebreakers and oil carriers are there which are being used in Arctic Sea, the Yamal area. Now this is the timeline of nuclear power. In 1940, the power started in nuclear propulsion. 53, they made a new naval test reactor Mark 1. 55, USS Nautilus was put with a nuclear reactor, and 26 submarines already they had, and 30. And first, they also tried in 1959 a nuclear powered merchant ship, NS Savannah. But after that, they have not made any more efforts in this line. Russia also did the same. They started with nuclear submarines K3, and gradually, but they went into commercial nuclear icebreaker Lenin in 1957, much earlier than US went into it, and they have a icebreaker fleet which is fully nuclear, because in ice breaking conditions you need tremendous power to overcome the ice. So ice can be as thick as a meter plus, and maybe more, 1 meter, 2 meter ice. So there you need tremendous power to overcome the situation. Now there are types of reactors which can be, used in marine conditions. One is a small modular light water reactor. This is where the coolant is water, moderator is water. I hope everybody is aware about moderators. Moderators are the one which keep a control. They are basically the control for the reactors. Fuel is a low enriched uranium in the form of ceramic pellets. Now sodium fast reactors. Here the coolant is a sodium metal or sodium potassium combination. Moderator is not required in this because sodium itself acts as a moderator. And they used fuel is high, I'd say low enriched uranium, HALU. Then lead fast reactors, where the coolant is lead. Moderator is not required because lead is a good absorber of neutrons and protons. So lead is able to control, prevent the nuclear from running away. And the fuel is same, high SA low enriched uranium. Now another type is the fluoride high reactor, FHR. Now here the coolant is a more fluoride molten salts. The moderator, because this is not able to control the neutrons and protons, so they need a graphite rod as moderators. These graphite rods absorb the neutrons and the protons and prevent the reactor from running away and controlling. And the fuel they use is tri-structural isotropic triso fuel, it's called, and that is the one. I am sure everybody is aware that in nuclear power, we have a primary cycle and a secondary cycle. The primary cycle is what we are talking about. The secondary cycle will have another set of coolers which is being heated by the primary cycle. Now we have molten salt reactors, MSR. Again, the salts are there. The moderator is necessary here. It's a graphite. Fuel is dissolved uranium, thorium, or mixed oxide in molten salt content. Then high temperature gas cooled reactors, HTGR, they have an inert gas like helium or carbon dioxide being used for as a coolant. Here also we need a graphite to act as moderator because these gases are not absorbing the neutrons and protons to control the reactor. And the fuel is triso, the same tri-structural isotropic fuel. This is one. And now they have heat pipe type reactors, categories of reactors. There can be 1 kilowatt to 30 kilowatt, 1 megawatt to 30 kilowatt, which can be fitted on a flatbed reactor. See, the size to power is a flatbed truck would be not more than 10 meter or 15 meter long. And it produces almost power as 30 megawatt, which is a huge amount of power. And then we have 20 to 300 megawatt small modular reactors. Because most of the ship requirement falls between actually 5 megawatt to 80 megawatt. The ship power requirement, most of the biggest ships right now, the container ship, which everybody must have, the one which got stuck in Suez Canal. They have almost 90,000, 80,000 plus kilowatt, 80 megawatt power requirement is there. Then they have the bigger reactors which are commercially not, cannot be used because they are for power generation up to 1,600 megawatt reactors. So they're not. Ours is mostly the small reactors and small nuclear modular reactors. So this is the one which can be, modified for the marine use. I think I'm done, and I hope everybody liked it. And any questions?
Yes, sir. Participants who have any questions, I think you can open up. You can unmute and you can ask.
Is that nuclear is commercially viable, like carrying container capacity? You feel so?
Come back, sir.
Is that nuclear power is commercially viable for carrying cargo?
Yes, nuclear power, sir, they have used in 1959 in US, Savannah. Basically, the problem is because the nuclear waste can be used for making bombs. That is one of the, I feel, one of the, hesitation in allowing nuclear power from commercial marine use, because then nobody has a control over it actually. A ship can be hijacked and that nuclear reactor can
Yes.
be used for wrong purposes. Possibly that is the hesitation on the part of the regulators and countries in for commercial use in shipping actually.
And investment also quite high, I believe. Very high
Yes, sir.
investment.
Yes, sir. Hi, but once what happens, sir, once it
I think your audio is stopped. Hello,
I think, yes, sir.
it's coming back.
hello.
Yes,
I
sir. You're
can hear
audible,
you.
sir.
Yeah, audible. Please go ahead, Mr. Singh, please go ahead. I think you lost the connection.
Yes, sir. Yeah, I'll just try him.
He's back now. Yes, Mr. Vijay, we can see you. Can go ahead.
Sir, are we audible, sir, to you? VP Singh, sir?
No, sir. No, sir.
Sir, I think he's trying.
I think he's trying.
But, sir, your audio to be connected, sir. Your audio is not connected.
Yeah, we cannot hear you.
Sir, audio is not connected. Only video is connected.
They're posted in chat box. Please check.
Hello.
Yeah, we can hear
Yeah,
you, please. Yeah.
Can you? Yeah. Okay. My system froze actually. I don't know what happened. So I have come on the I went on mobile, but I'm back.
Okay, okay.
Any
that's
other
fine.
questions, sir? Hello?
Yes, sir. Yes, sir. We are audible, sir.
We are audible.
Yeah,
Anybody else?
Anybody else? Question?
Any of the speakers?
Sir, we cannot switch on the mic.
His sound is on now.
Yeah, my sound is on.
Yes, sir. No, anyone is having any
Doubts, you can clear now.
questions or doubts, I think they can ask.
Sir, my name is Kumar PR. I am from Thrissur IEI local chapter, Honorary Secretary. Can you hear me?
Yeah, we
Yes,
can
sir.
hear
Yes,
you.
sir. We
Please
can
go
hear you,
ahead.
sir.
Thank you, sir. Sir, I have a small doubt.
Yes,
As
please.
we heard, shipping is causing a lot of, safest mode of transportation with regards to pollution. But
Yes.
some people say shipping is the most pollutant. It is equivalent to 5 million cars in America and all. I'm not sure about it. Can you please, VP Singh sir, can you please tell me something about this, which is connected with hydrogen technology? I think it won't be materialized within 5 or 10 years, right? It is under because of the complexity. Still, we are using fossil fuel or whatever available source of energy in shipping. So how come
Yes,
it is
true.
become safest one? Marine life is more affected than land mass, right? So, Singh sir, can you enlighten some or shed some light on it?
Sir, actually, IMO is putting a very ambitious target. Shipping, as you said, is only consuming 300 million tons of fuel every year and producing as much as only what Japan is producing, a greenhouse gas. But this is a cumulative because shipping is not only for one country, it is for all the countries, the 212, whatever countries are there. It is all. So shipping is a very net, I think 4 or 5% or 6%
3%,
pollution
sir.
is coming out of
3%.
shipping.
3% of the total. Of pollution,
So
3%
it
only.
is a very low. Only thing is what is happening that International Maritime Organization is making all efforts to be a very net zero emission. They put a very ambitious target, which I also feel is very difficult to achieve by 2050 unless they go into nuclear. That is the only one which I feel can solve all the problems of greenhouse gases. Because hydrogen also, for producing hydrogen, you require electricity. And then for producing electricity, we need, unless they can find some other technology which can split the water into hydrogen and oxygen cheaper and without the use of electricity. So electricity if required, then there will be coal thermal plants running or nuclear plants running. So what I believe that probably nuclear technology is the one which will be the need of the future, which will probably be able to satisfy the world's hunger for energy actually. That is the one which has a minimum greenhouse gases in itself. Because all other fuels have carbon, any other, even methanol or methanol will have carbon. Ammonia doesn't have carbon, but ammonia has other issues also. And even ethanol, we are talking about biofuel ethanol. Ethanol the same, it has carbon component. So it is next to impossible to get CO2 out of the system unless we go nuclear plus hydrogen. I think that is the two which together may be able to sort out the world CO2 problem. Anything else, sir?
Yes, sir. If,
So, sir, thank you very much.
Okay, thank you. Thank you.
yes, sir. Anyone is having the final we can have one questions.
Good evening,
Okay.
sir.
Yes.
I am a student of class 10. I'm audible.
Yeah,
Yes, yes.
you are audible.
Sir, I have done my project in green hydrogen fuel, sir. And
Right.
ammonia also.
Right.
That is useful for rocket fuels, actually. But nowadays we heard about the news that Toyota is building their hydrogen engine, which they are going to utilize in their cars also. So how the hydrogen fuel will be efficiently used in shipping technology? Is that possible to come to replace normal shipping technology with the hydrogen technology?
Thing is, hydrogen, the power density is low actually. So for the same amount of energy requirement, we need we need to carry 4 times more in terms of volume or the mass. That is one of the big lacunas, because what will happen if you carry more 4 times, then the shipping is a commercial venture. So we have to reduce the amount of cargo also carrying. Whereas, I mean, if some ship is consuming, say, 20 tons per day of fuel oil, with hydrogen, they'll have to carry 80 tons of fuel. And say it is a 20 days voyage. So that amount goes very high. The cargo capacity will, so green hydrogen, some prototypes may come into shipping, in the coastal shipping, but bigger ocean voyages, I don't see any. I mean, it is being pushed upon, but I don't see much commercial viability of this.
Okay, sir. Thank you, sir.
Thank
Sir,
you.
so one more doubt. Shall I?
Yes. Yeah, sure.
Sir, IMO has proposed a very ambitious target of 40% reduction in 2008 emissions by
Yes.
2030. Only 5.5 years more left in the date. How is it possible to reduce such a high carbon emission? Is it really
Well,
realistic or
yeah, it is actually a very ambitious target. And what I believe what they will do is they will go for slow steaming. Every ship which can complete a voyage in 10 days will do in 13 days or 14 days. And then you will see a drastic reduction in CO2 emissions. As I showed on that one of the slides, where if you reduce speed by 25%, your fuel consumption goes by 58% reduction. So that is one of the ways that they can try and achieve. Ask all the ships to do slow steaming so that the greenhouse gases are reduced. So this way, this is actually not taking out the carbon. Only thing is we are consuming less for the same. Only thing the time will increase. Steaming time will increase, and for that, then more number of ships have to come. That percentage will have to also go up. Thank you.
thank you, sir. Thank you.
Yes, sir. So I think we had a. Anybody is there? So thank you so much, sir. I think we can come to the conclusion. Once again, I think it's very the important topic of today's scenario, the green technology. It may not be only for the marine engineering; it is completely getting inside all the discipline. So, especially, I think our VK Singh sir has joined the today lecture for our Tamil Nadu State Center, and we have a good participants from the students category as well as from other center like Tiruchur also have joined, and they got a good amazing information. So I take this opportunity in thanking our speaker because sir has given in a short period of notice, because we used to see like the UP State Center is organizing so many events. So I think sir is one of the important speaker that we have to showcase our Tamil Nadu State Center. So thank you so much, sir. Within a short period of time, you have given your concurrence and you have delivered the lecture. Very important. And even though like you are a chief engineer retired, the wisdom what you want to spread it to across the younger generation is very important, and that you are doing it through IEI. So I thank our VP Singh sir for giving us a wonderful evening, especially in the green technology for our engineering disciplines. Once again, thank you so much, sir, from joining through online.
Thank you, Honorary Secretary Gokul sir and Dr. Karthikeyan, the chairman. I'm honored, and I thank all the speakers. It was a very nice session and interactive, and I appreciate that. Thank you all, and good night.
Yes, sir. So with this, I'll just deliver my vote of thanks. So I thank the speaker who have joined from our Uttar Pradesh State Center on the topic of green technology, upcoming green technology in the marine engineering. And also I extend my thanks to our chairman, Dr. V. Karthikeyan, sir, who always been a shoulder to our Tamil Nadu State Center in organizing many events. I extend my thanks to our committee member, Muthuswamy sir. So who always supports. I think maybe the week in the last 2 weeks, I think we had our Maritime Day celebration from Marine Engineering, and now we have again with our VP Singh sir. So definitely, I think Marine is taking a good dimensions in organizing many events. Thank you so much, sir. Also, I extend my thanks to all our committee members who have joined in the August evening, and also I extend my thanks to our the local like centers and also state centers of other parts of our country, especially Thrissur, who have joined from Kerala and given a query also. And also I thank to all the faculty members and the students members who always enrich to get the knowledge of the speaker. Thank you so much. And with all the things, I thank our coordinators, Alagradi, as well as Lalita madam, for making this event successful. Thank you so much to all. Thank you, sir.
Thank you, sir, VP Singh, and a good day.
Yes.
Thank you, sir. Bye. Good night, sir.
And we will meet up, sir, in Chennai when you're planning.